We'll talk about how to find percentiles at a certain value and how to find the percent of data below or above a value shortly. But first I want to touch on the 68, 95, 99.7 rule. With this rule, we can approximate how much data is between values as long as those values lie along our standard deviations. So you'll notice the first row I have here is just the mean, 1 standard deviation, 2 standard deviations, etc. And in blue below that, I have the values of that test score, where I had the mean test score was an 80 and the standard deviation is 83. The 68, 95, 99.7 rule says approximately 68% of all of the data is within 1 standard deviation of the mean. So that means approximately 68% of the data is between 77 and 83 for the test scores. So that would be from here to here. This is about 68% of the data. If I wanted to look further out, within 2 standard deviations, between here at 86 and down here at 74, this would have 95% of the data. So in blue, all of that is about 95%. Now, where did I even get these values from? If the mean is 80, if I go up 1 standard deviation, I take 80 plus 3 to get 83. Then to go up to the second standard deviation, I do 83 plus 3 for 86. Go up 1 more to get 89. From the mean, if I do 80 minus 3, that's down 1 standard deviation, down to 77. Subtract 3 again, that's 2 standard deviations below. Subtract 3 again, that's 3 standard deviations below. Now the 99.7 comes from if I go 3 standard deviations above and below and highlight all of the data in here. This is 99.7% of the data. Okay. Now how can we break this down a little bit further? If I'm looking at a curve, my mean is here at 80. I'm going to draw a little dashed line there at 80. If I go 1 standard deviation up and 1 standard deviation down, all of this would be 68% of the data. Well, if all of that is 68%, what percent is from here over? From here to here, that will be half of 68%, which is 34%. Likewise, from here to here, we have another 34%. Okay. Then what's left on the outside with these stars is going to be the 100%, whoops, just kidding, 100%, which is underneath the curve in total, minus the 68%. If I do 100 minus 68, I get 32%. So these two stars represent 32% of the data. Right? But notice that they're symmetric, or at least we're pretending that my drawing is symmetric, which means of this 32%, half is on each side. Half of 32 is 16, so this star would be 16% of the data, and this star over here would also be 16% of the data. We can do the same thing with the 95%. If we look at the normal curve, we see that between -2 standard deviations and +2 standard deviations, in other words, 2 standard deviations below and 2 standard deviations above, we have 95% of the data. If we take 100%, well first, if we take that 95% and divide by 2, that means there's 47.5% between the mean and positive 2 standard deviations, and 47.5% of the data between the mean and going down 2 standard deviations. If we take 100% minus 95, we have 5% left, and that's between the two ends on the stars, so that's 2.5% on each end. Similarly, for the 99.7, we've got 99.7% in between 3 standard deviations below and 3 standard deviations above. That gives us 0.3% left, which means there's 0.15% at the tail end above 3 standard deviations and 0.15% at the tail below 3 standard deviations. This means that it is extremely unlikely that we would have any data that is above 3 standard deviations or below negative 3 standard deviations.